2, 3. Boom. Pages. All right. Okay. Simultaneous linear equations. The very first concept's fairly straightforward. It is obviously being able to graph linear equations, which are all lines. And lines are represented in the form of y equals mx plus b. They don't have a power. They're not divided or anything like that. So lines are in this form. And they're very easy to graph. There are two methods. The first method is table of value. So there it is, table of value, -1, 0, 1, and 2. Just sub it in. X is -1, X is 0, X is 1, X is 2. I don't know. And then to graph this one, X is -1, Y is -2, X is 0, Y is 0, X is 1, Y is 2, X is 2, Y is 4, X is 2, Y is 4. Something like that, and then I'm pretty sure we should all be able to draw a straight line through those 4 dots. Any questions?
No.
Pretty easy. All right, and then I mean that's just the same thing over and over again. Sketch the graph of the above lines and clearly label each line. All right, easy. Let's continue. All right, well, let's talk about simultaneous for a second. So as we're going to draw this, we're going to have this graph, right? So y equals 2x. So let's say it was that, for argument's sake for now. Y equals 2x. -2x plus 2. Y equals -2x plus 2. I'm going to do this one in a different way. Instead of table of values, I'm going to try to graph this using x and y intercepts. Does anyone remember how we graph these using x intercepts and y intercepts, or what we know about the x intercept or the y intercept? Something equal to 0, x intercept. Y equals 0.
Yeah.
And then y intercept.
X equals
0.
That was the idea. So I think this is a more powerful method. Obviously, you're not going to go and do table values every time. So if you want to be at the top of the state, you should be doing it using x and y intercept. So y intercept, you let x equal to 0. When x is 0, you obviously get y equals to 2. That's simple. When y equals to 0, there's a little bit of algebra required, right? Because that bit there is 0. So it looks something like this. There it is. And then you know you're solving for x. So in this case, you probably would have brought this over, and then you would have got x equals to 1. All right. Any questions?
No.
So x equals to 1, y equals to 2, and then that's all you need to draw your equation or draw your line. We get that? Okay. What did I need to say? We've got x and y intercepts. That's good. We've got 1 and 2. We learn how to do it. So you can tell your y intercepts a little bit easier because you just go, that's 0 and it's just 2. This one, when you're making y equals to 0, you still have to solve for x. So a bit of math or a bit of equation work is required there. All right, simultaneous. Simultaneous is just the fact that you're going to have 2 lines like you have here, and you're just going to find the point where they meet. That's simultaneous. Is that okay? So in this case, let's just say it would be 1, 1. So if I want to find where these 2 lines meet, I would technically draw them accurately, as accurate as I can, and then find where they both meet, which would be 1 and 1. All right, that makes sense. Any questions there?
Nope.
So the idea of what we're going to be doing is essentially working out these points. All right. Let's see. Again, let me just do a bit of a recap from year 11. Y equals mx plus b. What does m stand for?
The gradient.
Gradient. And obviously, what does b stand for? Do we remember that? Or it's right here.
Y-intercept.
And if you remember what I just did above, what do you know about the y-intercept? You know something equals to 0.
X equals 0.
See, if you let x equal to 0, x 0, this is gone, m times 0 is 0, you're going to get y equals to b. So if you ever forget, just remember the y-intercept is the letter by itself, or if you're going to let x equal to 0, this bit's going to disappear anyways, and then you're just going to get y equals to b. All right, all good. So this is your gradient, and obviously this is your y-intercept. So here we go. Liam receives a fixed amount of pocket money each week. Full stop. Out of these two here, M and B, which one do you think would be the fixed amount? What would be the fixed amount, do you think?
Would it
All
be
right.
B?
Yeah, it would be 2x plus 3. The thing is, 3 is always 3. Like, it doesn't really make a difference, right? With this one here, the reason why it's not fixed is because as x changes, this number changes. So as x is 1, this becomes 2. As x is 2, this becomes 4. As x is 3, this becomes 6, and so on. So in terms of variables and fixed, I think that's a good point to make, because you will see this a fair bit in your course as well. This would be fixed. This would be variable. Well, let's say, again, before I get started down here then, let's say I was a plumber, right? And you call me up and say, Sam, I've got a blocked pipe, I need you to come and help me out. I go, okay, no problems. I charge $100 call out fee. And then I charge $50 per hour. And then I charge $50 per hour to obviously fix it. Do you want to go ahead? Well, you kind of know how this works. How much is it going to cost you? Well, the cost is $100 regardless, right? It doesn't matter if I work or not, it's going to cost you $100. But then if I decide to work, or if you do go ahead, it will cost you $100 plus $50 for every hour after that.
Yeah.
So this kind of makes sense. And can you see how this is your fixed cost?
Yeah.
It doesn't make a difference. It's fixed. That's your B. And this is your variable. As I work more, I get paid more. Or it costs you more, whatever. Make sense?
Yeah.
Done. Let's do it. Anyone confused?
No.
Done. Let's have a read of here. And I think as you see the applications, it'll make even more sense. So Liam receives a fixed amount of pocket money each week. So, right. In addition, if Liam chooses to help his mother, she gives him an extra amount per hour for the time spent. And I just pretty much explained that. The graph shows the amount of money Liam might receive in pocket money each week. So, it doesn't work. He gets paid how much, obviously. And then, as he works, he gets paid a little bit more every hour. All right, so what is the intercept on the vertical axis? On the vertical axis, what's the intercept? It's obviously
5.
What does the intercept on the vertical axis represent?
The fixed. Yeah.
Simple. You know what every question in your exam is going to say, right? It's going to pretty much be this. Because this is year 12 now. We're not talking about year 11. So everything that you learn is tested in year 12. So the fixed amount Liam receives. Done. What is the gradient of this line? All right, well, gradient, we know we can do it through.
Rise over run.
The only problem with it is you always check your slope. Now, it's pretty obvious this one's sloped to the right, so it's positive. But just be careful. If it was this way, you still do rise over run, but it's negative. Just keep that in mind. All right, rise over run. Let's find something that we could use. Oh, these are These are annoying.
Line, hopefully.
That one, but it's just a bit under. It's just a bit to the left. Oh well, I guess we'll go for this, and we'll say. I can't say that's exactly halfway, right? I think
No.
halfway would have been there. So I'm going to go with um, halfway of 5 and 10 is 7.5. I'll go with 7.
Mm-hmm.
There will be leniency. So if you decide to go for 6.5, that's okay as well. But if you went for 7.5, I think that wouldn't be accepted because we would have assumed 7.5 would be somewhere a bit more halfway between the two. So just so you know. All good. And then there's my little right angle triangle this way or this way, however you guys see it. What's my rise from here to here?
2.
Over my run, which is 2. Right? What does the gradient represent? So I want to say it. Liam's. Think of this guy.
Yeah.
What does my gradient represent? Take a guess. If it was worth $1 million, you're in the hot seat. What would you say? Come on, seriously, what would you say? Represents Liam's.
How much pocket money he gets?
Ooh, no, pocket money would be the whole total amount. So it would be, in this sense, it would be y equals mx plus b. That's the y. That would be how much pocket money he gets. We just got the m.
Oh, is it how much extra he gets?
Uh, yes, instead of saying the word extra,
Um,
extra, what? Extra per
per
hour.
hour.
If you didn't say his hourly rate, you're not saying it right. So the gradient was my hourly rate.
Mm.
That's a variable. So what does the gradient represent? Liam's, I'll say extra amount for you because it's not wrong. It's just if you wrote extra amount only, that's wrong. Liam's extra amount
Per hour.
per hour. That's super important.
Yeah.
So and you can see it. Look, if he worked another hour, which means he worked 2 hours, he gets paid $9, which makes sense because he's got $2 for working, $2 for working, so $4 for working, plus $5 he gets paid anyways. Do you get that? If he worked 3 hours, he would have got paid, let's say, 11. Again, he got paid another $2. That's $6 from working and $5 for being her son. Yeah. All right, so you get the idea. Fixed variable. All right. Anyone not get this? Because this will be pretty much how your exams will be set out. And it will ask for this, like what does the gradient represent compared to what does the vertical axis represent? Okay. All right. All good.
Yeah.
Move on. First, I realized before I start, if you want, maybe in your exams and whatnot, I go, oh, gradient, negative. It's something you don't want to forget. Because it's very easy to say, oh, rise of a run is, let's say, 5, but then forget that it's actually -5. So little things like that that you think you'll forget as you do the question, then just write them down real quick. All good. Let's start. Dorian intends to ride a bicycle from Aden to Barton to raise money for the local hospital. The graph shows his expected distance from Barton in kilometers. So his distance, which is 90 kilometers away, and eventually he gets there and he arrives after 6 hours. I think that pretty much makes sense, right? What is the intercept on the vertical axis? What information does this intercept tell us? You can't say fixed amount. That would be wrong. So what does the 90 tell us now with respect to this context of this question? What information does this intercept tell us? Let's say you want to take. Yeah. Oh yeah. Go.
So it's the expected distance. So it's what they've said is what the from Aiden or whatever how you say it.
Yeah.
That's what they've said. How
you don't need to say that's what they've said. It's right. What information does this intercept tell us? The distance.
Yeah.
Don't make it harder than it is. The distance from Aiden to Barton. And then as time goes by, the distance is less and less. It's only 45 to go, 30 to go, 15 to go. You've reached it. Right, so a bit of a different context. What is the gradient of the line? Again, rise of a run. I will just pick any triangle. Let's just pick this one. My rise from here to here is 45. My run is 1, 2, 3.
Okay.
But then you got to remember it's negative. So we'll put a negative in there so you guys remember that's a negative. And you know that that's true because he's losing 15 Ks every time. What information does the gradient tell us? Okay, he's losing 15K every time. Does anyone think they know what that means in terms of, again, this context? What does this gradient tell us?
So is it like each hour he gets 15 minutes?
Yes. And can you tell me the word we usually use for that? Say what you said again.
Okay.
Each hour.
Each hour he gets. What? Let me think. I don't even know. I forgot.
Each hour he gets 15 kilometers.
15 kilometers closer to, like.
Right. Correct. Which means. And when I said, what's that single word that we use to describe what you just said? It starts with S.
I don't know.
D, distance. T, time. S, each hour.
Distance.
15 kilometers each hour. Girls, anybody else can help her out? Dahlia? Distance, time.
Speed.
S. Yep, that's the one.
Oh.
Speed. Aren't you? Doesn't it mean that you're traveling 15 kilometers per hour?
Yes.
If you're losing every hour 15 kilometers, that means you're finding the speed. He is traveling at a speed of 15 kilometers per hour. You might have got away with saying he's losing, or he's getting closer each hour by 15 kilometers. Because you said each hour, I think you'll get away and you'll get full marks.
Okay.
But the word, I mean, for us to see that you really know what you're doing would be that word there. That just tells us, yep, you really get it. We're not even going to look at anything else, really. What is the equation of the line? I think you guys know it. The gradient is there. Your y-intercept is there. Just plug it all together. So the equation is, I don't know, y equals negative 15 times time. I should have said d. D equals, sorry. D equals negative 15 t, so that's your y, that's your x. So what, d equals negative 15t plus 90.
Could you put like y equals minus 15x plus 90, or is that wrong?
Look, in the HSC, so there's two different markers. HSC, not wrong. School, because they they need to teach you and they go through a punishment system. Unfortunately, I think you'll get it wrong at school. So in the HSC you won't, because it works through a reward system. So you start off in the HSC, the way they mark, you get, like, let's just say this whole question was worth 6 marks.
Yeah.
They start you off at 6 marks, and then they ask themselves, okay, did this person wrote this? Now, does that warrant itself losing a mark? So do we give them a 5 out of 6? Or no, it's pretty close to it. Now we're going to keep it a 6 out of 6. Whereas your teachers work through, like I said, the opposite way. So they start off at 0 out of 6, and then they go, okay, do we award them a mark for this?
Right.
And then they go, oh, well, no, that's not really the same, so we can't award them the mark. Does that make sense? So school, they're going to work a little bit differently because of the fact that they've got to still teach you guys to do things right. But by the time you come to the HSC, no, they don't really care about that stuff as much. We just need to see that you really understand your stuff, and either one's fine. Okay, good question. But I mean, yeah, that's y, that's x. It's not that hard for you to obviously realize that as well. All good. There is another question I want to add to F, which gets asked more in the HSC period, but I mean, it could come up in your school exams as well. F, it'll say, what is the problem with this? What is a problem that could arise, with, I don't know, with this model, let's say, that we've just done? What's the problem that could arise with this model? There's a few ways to look at it. You could obviously look at it like that, and you can look at it from the graph. What's a problem? Or even another word they use is the limiting factor. Like,
what would one be related to the graph?
Well, it's kind of the same thing. The one with the graph is the same answer that I'm about to say with this one.
Okay.
Maybe just think of your normal graphs and what's so special about this one, and what happens as this continues, maybe. So the limiting factor, or the problem with this model, is that the time, it only works for time being up to 6.
Yeah, that's
If time was 7, what's going to happen?
Yeah, it'll go below it.
You go below, which means you're going to have negative distance, and that's a big problem. So what is a problem that could arise with this model, or what is the limiting factor? It only works for time being between 0 and 6. Anything after that, you can't model because you're going to get to negative distance, which is not allowed.
Yeah.
Does that make sense to everybody?
Yeah.
And it's usually the same style of problem, just so you know. So it's not like the problem's ever going to change. It's always going to be because you can't model it. But be careful. Sometimes they've been because they know students start to memorize the answers and then they just change it around. Let's say this was time and this was temperature, and then students still write this like it only works for time, and that's wrong because what do we know about temperature?
It can go to negative.
It can go negative, so that one's actually okay. So you got to be careful. You can't just always say the same thing. So that one, what's the limiting problem? Well, there isn't any for the time and temperature in this particular context. Okay, good stuff. All right, this is pretty much what we just did before. You'll draw one, you'll draw the other. Wherever they meet is your point of intersection or you'll solve simultaneously. Does anyone actually need me to do this, or does that make sense when I say draw one, draw the other one? Pretty much that point there is the answer we need for C.
No, that makes sense.
Yeah, I get it.
Yeah.
Yeah, these ones are okay. Let's see if we can find it. Maybe, I guess we'll do this one. Using the values from x equals 0. Ah, no, I'm not bothered. Find the point of intersection. But yeah, same thing. I can do it graphically. Look, we can cheat a little bit. We'll open up our good friend Desmos and just put these graphs in just so you guys can see exactly what is happening. Y equals 60 plus 2x, 20x, and the other one is y equals 300 minus 40x. All right, here it is. What's happening? There it is. All right. So let's assume you have graphed these, and pretty much we can see that they will intersect at y being 140 and at x being whatever this value is. Let's scroll down all the way. X being probably 10, I think is what I can see. 40, 30, 20, 10, oh no, probably less. 7.5.
Huh.
Something like that. I'm sure we can click on it. There. No, X is 4. 4 and 140. So you guys get the idea. You'll draw them, and I'm sure the scale they've given you here, let's have a look at the scale. Yeah, 1, 2, 3, 4. They've zoomed it in so that you'll get it pretty much there.
Mm-hmm.
And that's where they should meet. All right. So nothing too difficult as long as you graph these correctly. Very, very straightforward stuff. All right. And again, so this is all part of the same thing. So once you understand it, they're all going to keep occurring again and again and again and again. It's not really going to change. Oh, there you go. See, there's my question. Why is the model not accurate? Which we'll get to in a second. Maybe we'll do question 2. Explain why this model cannot be used. There you go. There's another one. Question 2, but we'll do that. I just want to make sure these are all the same. Very good break-even analysis. All right. Let's do question 2. If that's okay, then we'll move on. Question 2. A group of Year 12 students are going on an excursion to a chocolate factory. The cost C of hiring a bus licensed to seat 54 people involves a $200 booking fee plus $5 per person. Who wants to take a shot at writing an equation to calculate the cost of hiring a bus for N people? Very similar to my plumber question. For N people. It doesn't say for 54. It just says for N people. So
200
200
plus 5n.
plus 5n. That makes sense. There was one person, it'll cost you $205. 2 people, $210. Yeah, great work. What letter goes on your x-axis? This side.
Is it? Yeah, and yeah.
And then what letter goes onto your y-axis?
C.
C.
All right. Anyone have any questions about A, firstly?
No.
All right. Cool. Draw a graph. Again, n equals, you know that n is all the way up to 54. So let's say you're not going to do 1, 2, 3, 4. Let's say we'll do 5, 10. I think 5, 10, 15, 20, 25. Ugh, it's going to get really bad. But you guys get BID. There it is. And then starts off at 200 and then goes up by $5. So 205, 210, 220, and so on. So let's start off with 200, and then I think we'll just do 205, and yeah, I'm happy with that. Well, it's going to be really messy because it's only $5. So can you see if I'm going to sub in 5 into this, just so you guys understand, I'm going to get 225. If I sub in 10, I'm going to get 250.
Yeah.
So I'm actually not going to go up by 5s, I'm going up by 25s because of the scale I chose down here. So it's going to be 225, 250, 275, 300,
Okay, yeah.
325, 350, 375, and blah, blah, blah. All right, so at 200, that's just when n is 0. At 5, it's 225. At 10, it's 250. At 15, and then I think we know the answer after that. It's a straight line, so that's what needs to happen, right?
Yeah.
Okay. Any questions?
Nope.
No.
45 students and 5 teachers are going on. What is the cost? Oh. What's that? 250, 450? 400, 425, 450. Yep.
Yeah.
All right, and it says, why is the model not accurate for n bigger than 54?
Accurate.
Because it's in this case, it looks like I can just keep going, actually. So why is this model not accurate?
Well, there's only 54 people that are going on the trip, so.
No, there's not 54 people going on the trip. It's licensed to only have 54 people.
Yeah.
Do you get that? So if you have 55, you can't actually use this model because you don't need one bus. You need now 2 buses.
Yeah.
You get me? Right.
Yeah.
Why is the model not accurate? The bus can only hold
54.
a maximum of 54 people. Anything over 54 would need more buses. Let's say, and you didn't have to write all of this. I'm just trying to write everything we know would need more buses, hence a different equation. Let's just write hence a different model or a different equation. Make sense?
Yeah.
Simple? Anyone have any questions? You can see it's fairly similar to what we've just done. We've done about 3 or 4 units or exercises so far, and they've been pretty much the same thing over and over again. All right. Developing your actual simultaneous equations. So, let's say this. Develop, probably in this topic, I think this would be one of the worst completed sections. So, because just a lot of words that you've got to understand and put into equation form. So, develop an equation to represent the costs of n apples at 60 cents each. Well, that's very easy. You just write C equals 60 cents each times n. Right, this is 60 cents. If you didn't want to use 60, and you might forget it's cents, if you want it in dollars, it would be that. So this would be dollars, this would be in cents. Whatever you like. Doesn't say what C needs to be in. So yeah. C, X liters at $7 per liter, that would be 7X.
Yeah.
A taxi driver charges $4 plus $2 per kilometer. Write an equation for where cost is C in dollars now and n the number of kilometers. So C equals All right, Bianca, you might as well go first. C equals
Travel charges $4 plus 2 plus I'm not sure.
okay, you are. That's okay. Alyssa, you want to try it? Practice.
Does it start with 4
Sure, you can.
plus
Plus,
2?
good job. You could have also said 2n plus 4.
Okay.
I mean, that's fine as well. Doesn't really matter. Yep. So, Bianca, you get that? That's your variable. $2 per kilometer. So $2 times each kilometer plus an extra $4. Okay. Dahlia, use the equation to find the
I
cost
think
of a
she dropped
journey.
out.
She's out?
Yeah, I think maybe her internet or something.
Okay. What about Kara? Kara, are you there? No? Kara's, all right. Karina?
Yeah, I'm still here.
Let's do it. Use the equation to find the cost of a journey of 12 kilometers. So that means you know n is 12. So what are you going to write? C equals 2 times 12 plus 4. And then that's what, 24. 24 plus 4. It costs $28. Do you get that, Karina? How to use that equation? Karina? Let's see what's happening. Dahlia, can you hear me?
Yeah, it's just my microphone wasn't working.
Okay, working now. Kara, you can hear me as well now? Or is Kara's mic not working?
Okay.
That's okay. That's all
Our
right.
laptop is broken.
Okay, that's all right. What about Karina? Karina, can you hear me?
Yeah, I can. It's just cutting in and out. That's all.
Okay. And it's happened the whole time? Cutting in and out?
Not all the time. It's just been happening sometimes.
Okay, let's see how we go with this one then. Karina, let's stay with me with this one. The cost of an electrician is a $70 call-out fee plus $50 for every half hour or part thereof. For every half hour or part thereof. If P equals price in dollars and N equals number of half hours, write an equation linking P and N. Okay, so P is in dollars, price, and N is the number of half hours. So how much would you pay this person? So the price would be $70 call out fee plus $50 for every half hour. What do you reckon? P equals
Would it be 70 plus 50?
N?
Yeah.
N? Yeah.
Yeah. Karina, you agree? 70 plus 50 times the number of half hours times N.
Yeah.
You get that? And then the part thereof, just so you guys understand this, if I had a double I or part B or whatever, and it said Sam worked for 20 minutes, just 20 minutes, do I just get paid $70 because I didn't get paid because I didn't even make a half hour? No, the part thereof is even if it's a part of a half an hour, you'll still get paid $50.
Yeah, I did this actually my last lesson in maths. He was talking because we're doing like car insurance and stuff.
Yeah, that's there as well. Yep.
Yeah, and he was explaining what that meant.
That's what I said. In year 12, it starts to overlap. A lot of the stuff starts to overlap. So you guys got to keep that in mind. Another one would be if I work for 35 minutes. If I work for 35 minutes, that means I get paid $100 for this. So N equals 2. 2
Yeah.
half an hours, and then plus 70, which means I get paid $170. All right. Does that make sense to everybody?
Yeah.
I'll leave, I don't know, I'll leave that one and that one for you guys to do at your own time. Let's maybe look at question 6. It costs Anika $120 plus $8 for every t-shirt she makes, and then she sells them for $16 each. Using C for cost and S for sales, and the number of t-shirts for N. Write equations for C in terms of N and S in terms of N. Okay, hold on. So one thing at a time. We've got to first work out the cost. How much does it cost us? All right, Dahlia, can you try this one for me? Cost.
Okay, so it's 120 plus a.
And then N, number of shirts. You could, if they didn't give you the letters, which they usually don't in your exams, you can pick your own letter. So like N or X or whatever it is. If they did, then it's obviously, yeah, whatever letter they decided to pick. Okay, that's your cost, easy. And what's your S? So you're selling them for $16 each. So S equals?
So 16 N.
Simple, 16 times N. That's it, good job. And then eventually you will solve these two simultaneously. Let's say that one there would look something like this, that one there would look something like this, and then that right there will be called our break-even point, which is coming up soon. That means that's just the amount of shirts I need to sell so I can at least make all my costs back up. So we'll work that out in a second. But yeah, that's good. Great work. I think we'll leave the rest for you guys. It's pretty much the same thing again and again. So let's have a look at this, which means we're going to apply what we just did above. All right, here we go. Haley bakes and decorates incredible cakes and plans to sell them via an online sales page. She works out that her costs in dollars can be represented by the equation. All right, so they've already given that to you, where X is the number of cakes produced. Graph Haley's cost on the axis provided. Okay, so we start off, we're trying to graph this, right? We start off with your X and Y intercepts. I think that's the best thing you want to keep in mind. See how you're not going to do a table of values? So when X equals 0, when X is 0, you get cost is 250, which you know is the Y intercept. Right there. When C equals to 0, or when this value is equal to 0, you get 40x plus 250 equals 0. 40x plus 250 equals 0. Do we all understand that?
Mm-hmm.
And we're going to solve for x. There, and then x equals negative 250 on 40, which is negative 6.25. So x being negative 6.25 is somewhere here. Negative 6.25. So that means the graph is going to look something like this. And it's a very horrible graph for me, I know, but you'll see what I mean by that in a second. So when x equals to 5, when x is 5, this is the way that you're meant to do it, obviously, because you're meant to do it for a table of values. When x is 5, 40 times 5 plus 250 is what? That is 200 plus 250, that's 450. At 5, that's not a bad guess. At x equals 20, when x is 20, you're going to get 40 times 20 plus 250, and I think that can see that's 800 plus 250 is 1050, so at 20, it should have just been over. It should have just been there. Not a bad guess though. Something like that. Anyway, we're okay with that. You could have done whatever method you would have liked. Obviously, you want it more accurate when it's like this, so maybe that's why they go through a table of values. But you'll need your x and y intercepts for hyperbola, our next topic. Anyways, all good? Any questions at this stage? What is the gradient of the line? The gradient of the line is 40.
Mm-hmm.
What does it represent? What does this represent? Let's see. Work out that it costs in dollars can be represented by this equation where x is the number of cakes produced. X is the number of cakes produced. So her 40 represents the cost per cake.
Yeah, quick.
Per cake.
Mm-hmm.
Right? Because this cost is not per cake. This cost is her overall cost. Do we understand that?
Mm-hmm.
So that's her overall cost, which includes, let's say, $250 of rent or wages or electricity that she has to pay for. Whereas this is the cost per cake. As she makes more cakes, the cost increases. If Haley wants to break even after 20 cakes, how much does she need to charge per cake? So she wants to break even after 20 cakes. Okay, so the first thing you got to work out is what is her cost at 20 cakes? I think we worked it out here. Cost at 20 cakes equals $1,050.
Mm-hmm.
If she is to break even, that means she makes the same amount of money. She needs to sell each cake at 1,050 divided by 20. Does that make sense?
Yeah.
So she needs to sell it for $52.50. If she does, then it covers her cost of baking the cake, as well as her fixed costs. And then graph the line I equals 52.5x on the same axis. Okay, let's just graph this. So let's do a different graph. All right. I equals 52.5. So when x is 40, I'm going to sub it in. So 52.5 times 40, that gives me 2100. So at 40, it's 2100, somewhere there. When x is, I'm just guessing these, right? I'm just like, it's an estimate, sorry. 20, at 20, it is 1050, which is what we know. And at 5, it's 262. So this was 250. At 5, it's just a bit over there. Something like that. And then it starts from there. So we can see what it's doing. It's doing something like this. And then anything after 20 cakes, you're making some profit. Yes? And it's obviously meant to be a straight line. But because of my beautiful handwriting, I can't get it out like that right now. Any questions?
No.
No, that makes sense. That's your income. And then shade the profit zone. Oh, well, I think that just makes sense. Anyways, you're losing money here because the black one's on top. You've made the same amount of money. You have reached your profit zone here afterwards. Does that make sense?
Okay.
All right, done. Let's do another one. Oh, this is the same thing, so that's why I'm not going to do it. Let's do part 2. Let's try A to F. Yeah, let's try this one. Oh, let's do this since they gave us a table. All right. Question 2. The costs of buying and running two types of light globes are recorded in the tables below, where n equals number of hours, h equals the total cost of buying and running a halogen globe, and L is the total cost of buying and running an LED globe. So n is the number of hours, and these are the costs that's involved in running an LED compared to a halogen. And do we all know what halogen is in LED? Of course. Halogen, the old lights.
Yeah.
And LED are the new lights that are usually wider and whatever. But halogen, they've got that little wire connecting the two things, and then you got a little light. All right, whatever. Nothing interesting. What is the purchase price of an LED globe? What is the purchase price of an LED globe? Think about it. N, number of hours that it's running, total cost of buying and running. And okay, what is the purchase price? Alyssa, what do you think? What is the purchase price of an LED globe?
See.
What do you reckon?
Number of hours.
LED equals number of hours. It's saying 0 hours, 400 hours, 800 hours of running, 1200 hours of running. And this is the cost. 13, 15, 17.
So the one that says like N0.
Yeah, of course, right?
13.
The purchase price is when it hasn't even started running yet. That's how much it costs. $13.
Thought so.
Yeah, and then halogen obviously costs $3 because it's cheaper. Hasn't run yet. That's the way I would think about it. Number of hours hasn't run yet. What is the hourly cost of using a halogen globe? How much is it going up by?
6.
6. Sorry, it says hourly. Okay, good question. It's going up by 6. I think we all agree with that. But that's not every hour, is it? How many hours is that? $6 over 400 hours. So it costs $0.015 per hour. Yeah, be careful. I think that's a really good question to always recap over. It's very tempting to just go at 6. But you gotta remember it's going up by 400s. Represent the cost of both globes on the number plane opposite. Okay, so before I start, I think what I would like to do is write our equation for both of these. So our equation for this, H equals, we just realized it's going up by 0.015. So that's your what do you call it? Your gradient. So 0.015 H, N, sorry, number of hours, N plus, what's your fixed cost regardless if you're running it or not?
Is it 3?
Yeah, and
Yeah.
same thing here. L equals, we'll work out our gradient in a second, N plus $13. How do I find my gradient?
It's 4 over 4.
15 take away 13, so $2.
2, sorry, not 4, yeah.
$2 over 400. So obviously your LED, they're more expensive to buy at first, but they're cheaper to run.
Yeah.
That's the logic of them. So 0.005. And then it says obviously draw it. So when n is 0, I mean, you've got your table of values, so you didn't need your equations. I just need to know that you guys can find your equations. But let's do this. So let's start. Number of hours, 0. Let's do the first one. So we'll do this one in black, and then we'll do this one in green. We'll just do the green one first. So when n is 0, L is 13, right there. When n is 400, it is 15. When n is 800, it is 17, 15, 16, 17. 1200 should be 19. 1600 should be 21. 2000 should be 23. Something like that. This is 3, 9, 15, 15. 1200 should be 21. 1200 should be 21. 1600 should be 27. And 2000 should be 33. So you can see the cost of running the halogen is obviously cheaper at the beginning, but as you run it more and more, it gets more expensive, and vice versa. The cost here is more expensive, but overall, it's meant to be cheaper.
Yeah.
After how many hours is the total cost of the globes identical? Well, I mean, we haven't done a very good job, but let's just say if it was somewhere there, halfway between these two, we'll just say 1,000 hours. And then the life of a halogen globe is 2,000 hours. So that's it, like it finishes halogen after 2,000. You can't go past that. While an LED globe can last 40,000 hours. If the light is turned on for 4,000 hours, how much cheaper would it be to use an LED globe compared to a halogen globe, including the cost of the globes? Okay, well, if you wanted to use something for 4,000 hours, with the halogen globe, you would have to purchase it twice. Do we understand that?
Mm-hmm.
So halogen, purchase, times 2. So 2,000 plus 2,000 is 4,000 hours. So it's going to cost me $66. Do we understand that?
Yeah.
But with the LED, I don't need to purchase another one because it can keep going for 40,000 hours. So all I need to work out is how much does it cost me for 4,000? And that's where this equation is going to come in handy. So don't think our work goes for nothing. Right? It will come into hand. It will come into play. So yeah, for your LED, you're going to go, okay, it's going to cost you 0.005 times 4,000 hours plus 13. So plug that into our calculator. Times 4,000 plus 13. It will only cost you $33. How much cheaper would it be to use the LED? LED is $33 cheaper, obviously. Do you understand the logic of that? Why I timed this one by 2 and why this one I didn't times by 2, but how we actually needed the equation. Without the equation, you wouldn't have been able to get very far, right? Because how would you have worked out the cost of 4,000? You can't continue this graph until you get to 4,000. So you got to understand how to get these equations out, and they're not too hard. So literally just gradient, the difference between the two over run, and then plus your y-intercept, which is where obviously this bit will be 0. Okay. All right. Any questions?
No.
All right. All good. All right. Maybe. Let me have a quick look at how well we're doing. Oh, we are done. So hold on. I'm going to stop the recording.